I have time to think about what needs to be done. And yeah, while I was on the beach, I realized that the first thing I need to do is check out the Python formatting. We're going to put all the formatting into a single string. Oh yeah, we also need to run the language from the VS Code plugin. And we're going to run the whole thing. We're going to put all the formatting in a single string this time around, so we can get better printing on the CUDA side. And also, I need to do some research on how Python string so something like this. We could also splice it in. But you know, that would end up being troublesome. If the user uses these curly braces in Python, we need something else. Maybe we could just put all the stuff in a list and then convert them to strings and join them together. That would be much easier for me to parse. I mean, for the program to parse. That way we don't have to worry about special characters in strings. They be treated just as they should be. Text format price. Placeholders modifiers. It also has string interpolation. This is string interpolation. I guess they're calling them F strings. Left aligns the result, centralize the result. And this basically isn't good for me. We have to, if we needed to use this, then we need to write a custom op in the language to actually parse these curly braces, and that would be work which I don't want to do. Okay, how about Python string concatenation? Concatenation. What about not like this, but what about something like list join? Okay, let's go. Let's find a Python script somewhere. I mean, haven't I started this already? Okay, here's console.2. I suppose let's just do something by hand, and if we do, I'm not sure whether Python has this kind of method. I mean, I'm kind of thinking about the JavaScript here. It has a array join for concatenating strings. .NET has string concat, at least the F-sharp extension method. It's an F-sharp extension method, but I think the regular string class also has it. Python array string join. Oh yeah, I know it was something like this. In JavaScript, I think it's the opposite. You have the array on the left side and then you do a join on that. But here the join is on the separator itself. Okay, so you do it like and let's wipe everything else. Now we will run this Python debugger. I guess we need to print it. Yeah, this is how we're going to do string concatenation in Python. We're just going to put everything into a single array and then have the runtime concatenated. Like, but what if we have something which is not a string, like QEA23? Okay, we get a type error, but what's going on? Oh, it's yeah, for everything that's not a string, we're going to have to convert that to a string manually. And how are we going to format the floats so they show up correctly? Okay, so how is it done now? I think okay, we could do something like what, F6 or how is it done in the library? We have this thing and then format B and okay, so something like this. Oh, I see. Wait, what? Oh, this is inside a print statement. So let's get rid of this. 23, 45. Oh yeah, nah, great. Now it shows up as yeah. Now it has 6 decimal places. Okay, not bad. And we could put it together. We could just do a join on an empty string. This will join all of these together. Okay. Okay, so on the Python side, I guess we could just have an array and push these strings to it, and then join it all together. Well, that's the easiest way to do it. Of course, it would be great if... Okay, basically I understand how we want to do this in Python. Now, we're going to... I guess for now we could just do two different versions of print. One for the Python backend and one for the C backend, instead of trying to mix the two together. Like, already you can see, if you look here, how there are incompatibilities between the C and the Python side, because C doesn't do printing, I mean string formatting like this. So it's kind of pointless to have this on the Python side. It just makes things more complicated. And it's not really that difficult to iterate over pairs and records like this. We can just copy this. We're going to remove the join point unless the union is either a runtime variable or a recursive. If it's we're going to remove the join point here if the join point is recursive and a runtime variable. Otherwise, we're going to print it out just as it is. Oh, okay, not bad. I guess we'll do this from scratch. I'll show you how to do that proper print now, and we'll yeah, let's just focus on the C version. We're just going to listen to this over and over again. That's how I usually do. stop listening to the music. Can I actually stop it like this in the middle of the recording? Now let's think about this for a bit. Of course, this won't work. Trying to put a list into a printf would be inserting a completely wrong thing. What you have to do now is turn the list into a tuple. I mean, I'm just using a list here for simplicity. Because seriously, fuck working with the pairs everywhere. Who's going to do that? Okay, before we get ahead of ourselves, let's match. And let's not call this separator, this will be a format. I mean, if it's called nothing, then we can just ignore it. Otherwise, we need to do the print. Okay, we need to convert it to a tuple. I mean, we can do that list to tuple. List. I'm just sketching things out here. It's actually a good idea to when you're doing difficult things to get into the habit of doing that. We shouldn't consider this a complete program. So okay, here we have the PIB. Okay, let's make it P equals put. And the type of this is, yeah, it's unit. We'll also do okay, let's change the separator to what the hell is going on? Okay, not bad. Put separator. I want to change some of the things. Okay, here proper formatting actually does exist. Okay, but these separators should be put directly. Put sep. There's many things to do, so we have to take it step by step. Yeah, this should be write sep. I mean, put sep. Do we have anything else? No, not really. Okay. Oh no, oh, we also need this. Wait. I think in Python we need to, if you want a curly brace, we need to put two of them. Okay, this is nice. We need the list tuple, and we need to concatenate these strings. Oh, but the stuff here. Oh yeah, it doesn't have to be a string. Oh yeah. Okay. Exists TT. This is an existential. Oh crap. Now we cannot put them at least. Let me take a short break here. I didn't get much of a break. You know what we'll do is simply get rid of this. Forget about this. And instead of using a typed hash map, we'll use an untyped one. We have the key. And the default value will now be an unit type. It's pretty tricky to figure out how to do a separator. Okay, key value and key separator. I mean, this is perfectly fine here. It's going to be more complicated in the Python backend. That's why, you know, that is what is confusing here. But as a rule, we shouldn't let how it's going to be done in the Python backend stop us here. It's a mistake as a programmer to get distracted by concerns in other places. It's so awkward messing with tuples. Let's go in here. I forgot to add a case in string concatenation. DB. Empty tuples we're just going to ignore. Like, we don't need to either put them in the string builder or anything like that. Okay, let's publish this. In fact, you know, since we are added, let's add the CUDA printf thing. We're going to come to do it later, but we might as well do it now. Let's see, where's the block parsing? Printf is just such a pain in the ass. Format string. Okay, so what do we do here? Like match term s f and t. This is going to be we're going to be expecting a string literal here. And let and this can be anything. In that case, push I mean, is this a binary operation? I'm not sure. Whatever. Let's d printf, and we don't want the CSI common sub-expression substitution to rewrite these to a common variable. So, printf fnt str. I need to give the return type, and the return type of this is just the unit type. Easy enough. And if it's not a string literal, we'll just raise an error. The work on Spiral actually began before F# even had a string interpolation. So that's why you see me use the interpolator string here and sprintf in the various different places. Oh, okay, this works. Let's see, push bin up, no rewrite. We can check out how it's implemented. Push up, no rewrite. Push tight up. Oh, okay, so it just puts it in a list. Okay, it's fine. Now let's go into the CUDA backend. And the reason why we are doing this is because if you just use a macro, it will pass in the values as a tuple struct, and that's not something that we want. We need to do them here. So let's see, where exactly do we do it? Whatever, I'll just printf fmt str printf, and fmt, and no, I don't think we want the tuple data. That will, yeah, that will put this as a tuple. Instead, we want the arguments directly. So maybe args. Data 3 vars and then args. Yeah, it gets all the 3 variables in this data structure, and then it concatenates them together as separate arguments. But wait, we don't want the 3 variables, we also want the constants. Let's put a bookmark here, and how do we... we var... how was it called? Oh yeah, we have this thing. Turn var. Yeah, and how do we turn... data turn vars, okay. We have the data turn vars. And now we need the version of args that works on turn variables. Okay, let's check out all the uses of data turn vars. It's args quote. Oh yeah, this is easy enough. And it's giving us trouble. Yeah, this calls data turn vars on its own. Oh, lucky us. And yeah, now we have the printf. We're going to have to do something similar for the Python version, but it's going to have a different kind of... maybe it's going to have a format function, I'm not sure. Never mind that for now. Actually, with Python, it will lay things out as a tuple directly, so it's not a problem there. With Python, we have a lot more options than we do with C. So, okay, let's push this out. I mean, not on the VS Code Marketplace, but into the compiler folder. Let's run this. Get separator and get value. Put separator, put hashmat set. And this will be get separator. And we'll just extend the pair. This is why we've gone for an untyped dictionary. Okay, so here you have the value. We just need to get on with it. Format string. Oh yeah, we need put sep fnt. And this should be fmt. Take a look. We actually put the wrong key here. So here we have fmt. And this needs to be fmt. And now format is just we don't have to care about all this. We just get fmt, get value, and we have to make sure that fmt isn't. Okay, we can do this in the real segment formats. Real match fmt with and if it's anything else, what we'll do, print f fmt and str. But we also need to do the string concatenation thing. Oh, not bad. And now we set what we'll actually do is remove the keys. H key fmt key value. And what's the problem? It returns a boolean. Ignore. Okay, it's ignoring the boolean that comes from this. Great, now you have the flush. Put get. Yeah, I like this. And this is put menu. But you know, since we're not doing this in Python, we can just use a curly brace, no problem. At least I think we can print, no problem, the curly braces. Let's check it out. C online compiler. And okay, here we have the printf. And we put pro in curly braces. And yeah, it prints them just fine. Thank you, online C compiler. You are very convenient. And this would take so much time if we had to do it on our own machine locally. Okay, let's just check the types of these. Oh crap. Okay, so this will be string, and this will be object. I'm using a symbol type, simply is so it gets rid of the for alls, even in the top-down segment. I guess that is going to be get value. I guess the format here will be the unit type. That's fine. Even though we're in top-down segment, we don't have to care about these types exactly. The types. The types. This is a technique called type lying. It's an actual technique. At least in Spiral. You couldn't do this. You couldn't do something like this in .NET, but in Spiral you could. Oh yeah. And we also have to we want to optionally add a new line to the end of the format string. Okay, let's do this. Right. And is new line. And if is new line, then what? We need to put fmt Like, we didn't even put in this error type here. We could have just done. We could have just commented all of this out like this. Okay, great. I mean, yeah, this is workable. We're also going to have to pass the hash set into this instead of just down. But in that case, we're also going to have to pass the keys. Okay, never mind. Never mind this for now. Let's test it out. And it's going to, yeah, it's going to have to be on the CUDA backend. Alright, true. And we have to actually do the test somewhere else. Open CUDA console. Open Corebase. And it's console CUDA. In normal main. And then run. And now this will execute on the GPU. What's the problem? Yeah, we needed the regular run. Now let's try something out. Write ln not bad. Let's build this. We have some error. And do we have the right backend selected? We do. For keys. What? Let me think about this. It's Git format. Cache map target. No. Otherwise, some. And the one who has to match the actual type here, for fuck's sake. I didn't realize this was an aspect of... Did I get... Okay, so... What do you here? Maybe we shouldn't just use this directly and okay, I know what we'll do. Get to default. Turns the default. And I misspelled this. It's kind of annoying to have to keep around. Oh, not bad, not bad, not bad, not bad. Get rid default. Oh, not bad. Let's try running this now. And let's check it out. I can't come with this now because all this library code. It's so atrocious. I wish we could put this in a separate file and just import it. But alright. Oh, wait, I'm not... If you look at here, we aren't actually flushing. We aren't calling flush anywhere. Flush. Explicit a component, a string, or a pair, then got to I32. What the hell? In records, Write value I32 P is put value put format like do these kinds of keys even do anything? Let's try put make the keys be like this. Oh wait, it actually compiles now. Wait, what the hell? Oh, I see. A through B. Okay, but we can put. No, we cannot put the keys in here directly. Oh yeah, that's right. Okay, let's run this. The reason why we cannot put the keys on the left side into the format string is because you can take ordinary strings and convert them into symbols, and you could have record keys that are any string that way, using string interpolation. Oh, perfect. Yeah, this actually works. Let's just do a tuple. I mean a pair type. For I64 5U8. Nice. Yeah, I like this. We aren't done. We have this template for the write function. Nominal. Okay, let me think about this. What we want to do here is a hash map. We want the key format. We want the key value. H key fmt key value. And as for this, let's make a write. Okay, let's put it here, for example, and then wait, is it the first or the second? Yeah, it's the first argument. Makes sense. Console config h key format key value. Not bad. False. Yeah, we want. Yeah, it would be great if we could factor this out. We'll create console config console config. Yes. Okay, that's one of the steps that we needed to do, because when we want to print out recursive structures like lists, if they aren't known at the compile time, we'll have to split the printing into several statements. So let's work on this. If the union type is X, then also we need a printable thing. Printable. Yes, going to be put console config. Yeah, look at this. And the reason why we are passing the console config in explicitly actually, I'm not sure whether that was a smart idea, but never mind that for now. Like, let's just move forward. I'm not going to justify myself. Maybe I'm wrong, but if we are, we're just going to. It's not a big deal. Prototype. Yeah. Because we need to pass it into printable. Yes. Yeah, I'm so dull today. As config and yes, printable. Yeah, we need to pass it here. And then we have, okay, here is nominal is, prototype has, then printable. Layout is X. Okay, this is fine. Like, I'm not even sure this would work. Forget about the layout types. Okay, so what I have to do is deal with unbox. I mean, over here we know that it's an union. Let's increase the body. Actually, we have to make this recursive. Rec. Oh, not bad, not bad. Okay, so this is oh yeah, this needs to be put sep. Oh damn. Okay, this is kind of annoying. How do we do this? How do we factor out the union body? We have the unbox. Let's pause for a bit here. Okay, I know a solution for this. Let's we're going to get a bit fancy. Okay, first of all, let's check out whether this is if heap union is x and var is x, then something else. Yeah, but we have the body here, body. This also needs to be put fmt, put fmt, put fmt. This needs to be a part of the formatting. If it's not a keep union that is also only run at runtime, then we just run the body. Otherwise, we run the body through the join point, and of course that will give an error because we'd also be passing compile time hash maps through the join point boundary, and that will give us an error when we try to do that. So that's a rush. It kind of strikes me how many exceptions now Spiral has in the language. Like, it used to be that you could pass anything through the join point, but now we can't. And of course it used to. Sorry, I got interrupted and forgot what I was talking about. Basically, I was lamenting the fact that in the past you could pass anything through join points, and now you cannot pass compile time hash maps and hash sets. And that all started when we had more than a single backend and couldn't pass anything else than an array or an array of. We couldn't pass anything except primitives or arrays of them. And now, when we added existentials, we kind of broke the type inference in the partial evaluator, because now an existential types has the same type as any other existential, regardless of what its top-down signature is, and the same goes for alls. But even so, I'm going to stand here and defend those decisions, because they do make the language better, and trying to get it to work perfectly would just make it worse. So it goes back to what I was saying. It's okay to do it 99% correct and then leave the other 1% to some other mechanism. It all started actually when I put the top-down segment instead of just using the bottom-up programming style of the old Spiral. Yeah, it kind of goes back when we're just putting new evolutionary aspects into the language. I guess only time will tell whether the language is evolving properly. It needs more people to try it out. Okay, so forget that. What this skip union is testing is whether the union type is a recursive one, and what this for is testing whether it's a runtime variable, and then we run it with a draw, put the body in a drawing point, and then do this, then evaluate it. But of course that wouldn't work, so what we could do... Okay, what we got to do, if we're passing it through the join point, we need to also pass the config. But if we pass the config, I mean, yeah, we can just pass the config here and then config it to write. But it kind of really breaks the succinct design. So I need to... Yeah, let me stop here so I can think about it. I mean, I already took a break, but I need another one. Today, maybe I need to stop the endless gaming sessions, but at least today I won't be going to the beach, so I'll be able to do a bit more than usual. Even though my work would be a lot more effective if I could finally stop playing games past 12 p.m. or 12 a.m. I mean. I have an idea. Okay, so what we're doing here is basically taking this unboxed union type and packing it up again. And if we call write over here from the top level, it will end up going into this branch, and it will get outputted correctly in a separate print statement. I mean, using a separate print statement will be generated to print out the recursive nominal. Okay, the only thing I'm wondering, I mean, maybe we could also do it like this, but I'm not sure whether that will work, unfortunately, because it's unboxing it here into the key and the value, and that would strip away the wrapper from the union type. We just get the key and the value here. We can do this because we're programming in the bottom-up segment, and even though I know that this is if we unbox it here again, I mean, if we do something like unbox X again, it would get optimized away, because the partial evaluator is keeping track of this, but I'm not sure whether it will really be unboxed inside of here. That's the thing. I think we are using the common sub-expression elimination dictionary to keep track of these changes. So we'll just create a new union type over here, and this one will have its values known at compile time. So it will be easy to print out. Yeah, it's perfect. We'll unbox X here, and here it will be known at compile time when it goes again into the write function, and then when it hits this, it will know what the value of X is at compile time, and it will unbox only that branch. Yeah, that's what I'm aiming for here. Recursion is pretty magical. Oh crap. And this needs a fucking type. I mean, why the hell am I doing this? The types of these are lies. Okay. Okay, let's not make this recursive. I cannot stand this. What we'll do is... Oh damn, we need to flush it at the end. I mean, the only problem is that we need to apply this fucking type. I guess it will be like whatever. X. There. Okay, I like this. I guess we can try it out. Oh, there's so many changes. Let's see whether this still builds. Yes, it does. And as you can see, the beauty of this is that every thread will print everything in the right order. For some reason, the semaphores don't really work well for us. Let's put some option types like sum, and then yeah, it works. And suppose we actually did this. This will now be a runtime variable. Wait, what's going on here? Ah, crap. It's pushing both of the cases. Okay, I forgot about this. What exactly do we do here? Okay, I'm not sure how to fix it right now. I need to think about this. Oh, let's do it. I had time to think about it, and we're going to do this. The main problem is that for some reason the global semaphores don't work correctly, so that's pretty much the main reason why I decided to do this redesign. So at the very least for regular types it should work even without those. We're going to have to figure out why the global semaphores, the binary semaphores don't lock and unlock up properly. But that's for later. Right now, we'll go with this. And this will ensure that it will have some consequences. It should print correctly, but it won't be in the proper order. Let me show you what I mean. So we're going to have to use semaphores, but I'll try to at least figure out why it's not, why in some cases it doesn't work properly. And mutable compiler type hash map needs to be made immutable before it can be passed into a join point. What the fuck? What? Or is prototype as printable? No, it's not going to printable. I don't think, the option type doesn't have a special printer. So commutable compiler type hash map. This is very strange. Why is it telling me that it's? Why will it be passing it inside of here? Right. Let's just comment this out for now, and if we try compiling this, what happens? Yeah, of course it works. Wait, why is it actually printing anything at all? Oh, it prints everything outside. And then, yeah, we get the error. Like, what's this right? Okay, this is very confusing for me, because it shouldn't be capturing the compile time hash map anywhere. This only captures x. Okay, let's do, x equals something like this. This doesn't give an error. What about this? This doesn't give an error. Okay, what about this? It doesn't give an error. I keep running the wrong file. This doesn't give an error. Oh, this doesn't give an error. Okay, I see. So, that's... Wait, what the hell is this even returning? I mean, this should be returning a unit type. If we build this, wait, what the hell is it doing? Wait, why is this union 0, union 1? What the hell is this union 0? I mean, okay, this... union 0 1. Oh yeah, this is the actual union type. Okay, no, this makes sense. And passes that union type to the function. Oh wait, it doesn't flush it. Oh yeah, we need to flush it first. Before we go into the join point, we need to flush the existing inputs. And then build. Oh, what the hell? Oh, this is pretty confusing. What about... okay, what about this? It creates the union, but it prints something weird at the end. There's nothing in this. Okay, okay, the behavior of this is completely unexpected to me. I have no idea what the hell is going on. I mean, okay, well, let's print a static write. What the hell is it? Print static. Maybe we are not applying it, the write function properly. Yeah, it's a function. So we haven't
Here we have the type, then the config, but we don't have whether to print the new line. Fuck. Is new line? Oh, yeah, false. So that's why it was returning the whole closure from this unbox thing, and of course that could end up capturing the compile type hash map, maybe. Oh yeah. It's not capturing the compile type hash map. It's creating a new one here and then returning it from a join point. So yeah, that's why we were getting that error. Okay, now we're running this. Oh, wonderful. As you can see now, it's printing the cases. Yeah, I anticipated that we need to print the recursive unions with separate print statements in a recursive manner, but I didn't think about that the runtime case for regular union types would be like this for stack-based union types. We just needed to flush them and then write them out. Yeah, this is a pretty elegant solution. Okay, so I guess the printing now works, but let me show you what happens when we run it. I mean, the compilation is proper, but oh, it won't print properly. Down. Let's see. Yeah, I expected an expression, and that would be where, yeah, right here. It has this comma. Okay, we're going to change that in the compiler. Core CUDA. Here's the printf. Match. With but if it's empty, then yes, not bad. We just do it like this. Let's run it again. Let's build this. Yeah, now we should be able to actually run it. And because these print statements are run using separate threads, as you can see, it's not what we want. So what do we do about this? Well, previously we had in the CUDA semaphore module, we have these binary semaphores, and we were using those for in order to block all the other threads from actually printing the stuff out. Of course, when we tried to use that to debug the reduction kernel, it didn't work. It didn't work properly. For some reason, in places we were getting nans. So yeah, we just had this static CUDA binary semaphore, and yeah, what do we do about this? Yeah, instead of using these semaphores, maybe we could create a global variable. Maybe the problem was simply that we were using multiple semaphores at the same time in reduction kernels. I'm not sure. Acquire release. Counting semaphore with one, and we have to be careful. If, for example, if we use the semaphore somewhere around here and it calls this function recursively, then we are still screwed. So we need something like a global semaphore just for this print function. Okay, I mean, who knows, maybe the problem is goes deeper in some CUDA library. I can't I just got an idea that it could be that the only possible reason, you know, why we were getting nans could be simply because these global semaphores are being allocated in separate static variables, like, for example, where is the fucking semaphore? Oh yeah, like we were using write element system, and every invocation of that, you know, it could be done in even though suppose we have a single function, but it could be passed into different join points, and those different join points, it could have different static variables. So maybe, yeah, so this isn't really the best way to have if we wanted to do proper printing. Instead, we need to make sure that only one possible variable could be used. So let's okay, let's try doing something like like this here. We're going to do global. Let's check out how we're actually doing. Here is, it needs to include the semaphores. And how is it actually creating them? binary semaphore. Let's pause just a bit. While I was in the bathroom, I figured out why we were getting those weird printing results when we were debugging the reduction kernel. Remember, we would put write ln system, and it would give us simply it would print out wrong things. It would print out nans. Whereas after we put sync threads directly after write ln system, something like that, it would start working. And I didn't understand that, but I realized just now why that ended up fixing things. Let's go into the CUDA. Oh, for fuck's sake, CUDA. Yeah, CUDA programming guide. Now cooperative groups. Let's take a look at the. I mean, I'm not sure exactly what I'm looking for, but it tells us that for the reduction. Yeah, here we have the reduction. Anyway, this is driving me crazy. But at any rate, for these operators to actually work, there are warp reduction. In fact, that's what we should be looking at the warp reduction operators. Warp. Let's see. Warp. Okay. Fuck this. Fuck this. What I want to say is that if you look at the manual and look at the various warp, shuffle, XOR, I mean, and shuffle up, shuffle down, whatever, all of them will say that they need all the threads to be present in order for this to work. In fact, all of those instructions, if you look at the PTX versions of them, they take the mask of the existing warps. So if you think about what this does, even if we assume that the binary semaphores are working perfectly, if this acquires the lock, then prints it out, then it releases it, this will end up causing the warp to diverge. Because it's not really a given that it will, once the first warp simply releases it here, that the rest of them will wait until it converges again. So in order to fix this, what we need to do is to do what? How do we get? Yeah, we need to create coalesced group. What the fuck was it called? Sorry for swearing, but this is driving me crazy. I mean, who is going to find anything at a moment's notice in the CUDA manual? So, okay, CG reduce. Oh yeah, coalesced threads. Yeah, what we need is this. And we know from going over the PTX manual that this just creates a mask of active warps in a particular branch. So, what I want to say is that we want to do this instead of something like sync threads in order to fix the problem, simply because the sync threads will synchronize the entire block, and that may end up causing end up freezing the kernel if this is done in an if branch. So what we have to do is make sure that we're actually synchronizing the warps in using the write operation. So collect threads, any all. How do we synchronize this? Oh yeah, here's the sync. Okay, here's the sync. Okay, let's create collect threads. We'll use this. We need to do this inside the semaphore. Threads. Okay, let's open cooperative groups. Wait, is the semaphore coming after? Let's close all of these. I cannot deal with all of these. Okay, the cooperative groups are at the end and the semaphore is closer to the beginning. Okay, let's do this. I mean, I don't think the cooperative groups are... Yeah, they're not operating the semaphores, so it should be fine to change the order. Okay, here we have the collect threads, and we have to synchronize on them. Let's see, do we have anything for that? I don't think I've added anything to synchronize on a cooperative group, on a QLS group. In all CG sync, by the way, I also figured out why it was constantly swapping the order. I thought this was an error in the CUDA library, but after thinking about it, that was wrong. The reason why we were getting that error is because this reduction internally, what it's doing is a butterfly reduce. Butterfly reduction. Okay, it's basically what it's doing is using shuffle XOR. So to do the reduction, I think if you look in the CUDA manual, you'll be able to find it. And okay, here's basically a visual representation of how it looks like. You can also do a reduction using a shuffle down. This is one example. This is how it looks like visually. And if we want to share all the values, we need to do a butterfly reduction. And this constantly ends up swapping the arguments. So it's no wonder that the ordering gets violated. And unfortunately, we are simply going to have to adjust the kernels that depend on that, so they base their ordering on the actual value of the element, which will be easy. So yeah, it's not a CUDA error. I have nothing to report to NVIDIA. I'm not going to hold it against them for using a butterfly reduction. It's my own fault for not realizing this sooner. You know, I have so much stuff in my head, so it's no wonder that I didn't realize it right away. I mean, when you're debugging, it's not like, and you see something weird getting printed, it's not like you have to play detective to figure out what's wrong. It's not like it comes with an explanation. It's not like an error ever comes with an explanation of exactly what you have to do to fix it. It requires some brain power. Yeah, the butterfly reduction requires the operation to be commutative. And the thing is, yeah, I already said that, but in the manual it says if you try running shuffle XOR sync with the diverged threads, then you'll get trouble. You'll get undefined behavior, and that's why we're getting those nans. So let's fix it. CG sync coalesce group, and yeah, it should be unit. And I guess this should be tile. Wait, it should be like this. Should be like sync, or should be something else. Okay, let's try it like this. And if this doesn't work, we'll just change it to cooperative groups colon sync. Let's just make this CG sync. Warp. Okay, let's make this warp active warp threads. Yeah, great. Now everybody will be able to understand what's going on here. And let's put all this on the same line. Yeah, and over here as well. In effect, we're going to remove these functions from the semaphore. This shouldn't be here, and every console.write from here on out will be just using some global binary semaphore. That way, there'll be zero possibility of there being an error. For example, due to different threads using different semaphores. Okay, for now, let me comment it out. So yeah, let's comment it out, and we are going to use the functionality here, except with a global semaphore. So oh, I see. Control Shift is, and Control Alt is. Control Alt zooms in for me and Control Shift zooms out. Interesting. And Alt is equals and Shift is underscore. And I mean, that's what the keys are key to. Hopefully they get hold the tab. I mean, the tab preferred flavor of the hold the tab soon. I mean, I think the guy who replied to me was something like the co-founder of the company, and he told me it will happen very soon. So who knows, maybe a week or two at most. I'm looking forward to it. Of course, I could have implemented to improve the key bindings earlier using the manual system, but I didn't want to bother with that. Okay, well, You're just going to get a reference to the global semaphore. That's how it will work. Okay, never mind that for now. Let me think. We have implemented CG sync. Now let's close all of this, and what do we need to do? Let's go back into console CUDA. Okay, now let's make a semaphore. CUDA semaphore. Oh yeah, this is it. Here's the binary semaphore. I'm just wondering how global variables work in CUDA again. I pretty much never use them, so I forgot. I mean, do you have to put in underscore global, or can I just put anything in the global scope? So CUDA binary semaphore, CUDA thread scope system. Okay, let me sit. It's hard to be on your feet. Okay, so we'll do this include, and then what? Okay, first, okay, here we have this. Let's open the semaphore again. It needs to be. This is in thread. CUDA binary semaphore. Okay, so this is how it's initialized. And create binary semaphore in grid. Oh, this is the count. No, wait, it isn't. When it's acquired, the semaphore actually decreases instead of increasing. Yeah, right. So that's why it needs to be initialized, that one. Okay, we can try it out. We'll do this. And this will be thread scope system. Oh, for fuck's sake, where are the scopes? Thread scope. CUDA thread scope system. Okay, let's do, main. Oh wait, we cannot do it here. Forget this. Okay, now we have the semaphore. Now, okay, let's CUDA binary semaphore in grid. And this will be console, and this will be 1. CUDA binary semaphore, and instead of scope, it needs to be CUDA thread scope system. Okay, let's just see whether this compiles at all. We'll build this. Yes, and this builds, and it should put it at the very top, I think. Yeah, right here. CUDA binary semaphore thread scope system console log. Oh, perfect. And we'll just acquire a reference to it. So let's see. We have this. Let's put it in print somewhere. What we'll do is acquire the semaphore. I mean a reference to it. Okay, here we have the semaphore. Create binary semaphore. What are they fucking called? Yeah, binary semaphore thread scope system. Okay. Binary semaphore thread scope system. Thread scope. Okay, often where is it? Oh, this is in core base. Why is console CUDA in core base? Now we've moved it. And this one needs to be deleted. Open core base. Open RFM. And we'll also open the semaphore here. So okay, now we actually have the semaphore. And it's kind of annoying to keep writing thread scope system. What the hell? So that's why I did it. Oh, okay. Oh yeah, it causes all kinds of issues. Ah, what the hell, I went too far. I guess I'll just open thread scope and then use these. Open thread scope. Why is it? Why is this unbound? Yeah, it becomes unbound for some reason if I put it after the semaphore. Maybe something overwrites it. If you look at the semaphore and yeah, it becomes a function. Fuck. Whatever. Let's just do it like this. Ref binary semaphore thread scope system. And we have to acquire the binary semaphore and then release it afterwards. Okay, let's. Yeah, we need to open the cooperative groups. Yeah, now that we have this, I think it should work. So now that we have, now that we actually have this, we could just use the previous version of print, and it will work anyway. But yeah, it's kind of, it's really a huge pain in the ass to have to keep writing to have to keep using the semaphore. So, but maybe for some things there is no choice but to use it. Like maybe for arrays on, maybe for when using custom tensors. But it's good to have it here as well. Okay, we will do this. We will do this. Okay, write semaphore is new line L. Let's factor all this out. true L. False L. Yeah, not bad. CG sync. Yes. Have to make sure. This is so the printer works in the yes, okay, this is perfect. Right, so for true. Yeah, now it should now you're actually using the printing function on the CUDA side. It should be a lot easier. That being said, we're going to have to do some real thinking about how we're actually going to replace that on the CUDA, in core base, because over there we don't have the access to the semaphore. I wonder, like, if in packages we could also maybe do core base. Yeah, it will complain that there's a duplicate name, so we cannot extend. The console doesn't even have to be in core base. We can just put, we could put the console here, and that would allow me to access it. It will allow us to access it anywhere. Yeah, but it needs to be part of the core library somehow. So I guess we'll have to make another thing. Maybe we should put this in semaphore. We'll see. Yeah, okay, we want console CUDA, console Python, and we'll figure out how to bring it together. Maybe we'll do something like core ext console. Yeah, something like that. There's no rule that we have to only have like 3 core libraries. We can just open core ext console and make use of it from there. I'm gonna write that. Okay, write semaphore. Yeah, that's fine. Yeah, everything here is perfect now as far as I'm concerned. Yeah, come to think of it, we sometimes see printing working very, very weirdly. Like, it could only, there have been instances where it could only print an array of 4 elements, but then it prints out 6 elements in an array. And there have been weird artifacts. Maybe that's due to the conflicts with the semaphores. I mean, we're going to find that out soon enough. Oh yeah, also before, I don't know why I... Did I say that the console lock increases? Okay, no, I won't even go into that. If I said something wrong, then... You know, my memory today isn't the best in the world. When this is acquired, the console lock decreases, and when it goes to 0, it cannot be acquired anymore. That's the way the binary semaphores work. And it's a good way of having them work. It's just what we need for the printf. Okay, and I think this is fine, but let's test it out. What am I doing here? Build, run. Let's see whether it works. Must be a class or namespace name. What? Binary semaphore, CUDA semaphore. Identifier v4 is undefined. What the hell? 299. Oh fuck. Oh, so this is how it actually. And here we have an initialized reference. Okay, let's change this. This is reference. This is v equals console log. Now if you build this, I mean this, CUDA std binary semaphore, CUDA thread scope system void. Okay, and we'll also copy this, like not here, but now let's start building this. And I guess we need to import the cooperative groups. Let me think. Where is that being done? Global. Wait, here we have the sync. And this is... Oh, I see. So we don't need the CG sync explicitly. Okay, require list sync. Okay, let's take a look at how the cooperative groups. Okay, let's look in Matmul. Using namespace, and we could cooperative groups. Oh, so this is how it was used here. So we need to, we need to import the cooperative groups. I mean, let's try it. Oh, maybe the problem is this one at the end here. Okay, this is driving me crazy. Let's... we're going to try to get it to work without the global. Okay, let's get that lock. And we can do that. Create a binary semaphore in grid. Oh, at least it compiles. And it's putting new lines where it shouldn't. Oh wait, I think I understand why that is. Accidentally. Oh really? If true. Wait, what the hell? Okay, first of all, let's figure out why this isn't written on a single line. At least for an example like this, it should work either way. Write semaphore. Printf. Oh, wait. I understand. Yeah, here we have the flash, but we don't actually want it to put in a new line unless this kernel really is over. So yeah, like this, and then when we do a flash here, we just pass in false. Now we build this. Oh yeah, now this works. Yeah, not bad. Let's see how it actually looks in the code. Yeah, now we're really taking care of all the cases. Okay, what I'll do is try to move it manually to the top level. Like here we have static CUDA, but now we'll have let's do it like this. If we try it like this, what we'll get? Yeah, we get some kind of error. Suppose we try doing a global, or maybe a device. Oh, great. Yeah, this is how we have to output it. So let's comment it in like this. Device CUDA binary semaphore. I mean, do we really need to import cooperative rules explicitly? We'll try disabling it later, but for now, let's try getting this to run. Yeah, why do we have this CUDA std counting semaphore? Why is it putting all these arguments here? Suppose we try doing it like this. Yeah, now it works. Yeah, so this is how it should be done. Now, if you look at the semaphore module, why is it printing that type in such a weird manner? CUDA std counting semaphore. Oh, so this is a count. Yeah, this is supposed to be a count, so why is it just passing a void into it? I mean, yeah, instead of doing this weird std thing, we could do it like this, for example, maybe. And this count, counting semaphore scope. Oh, wait, I mean, how does it even know? Suppose we have this, like, what's even the count here? 1i32. How does it know this? Based on what exactly? Acquire, lock. Oh yeah, this is. Yeah, the binary semaphore has a count of 1, I think. Yes. But if you pass it a type literal like this, I mean, if it's a count, shouldn't it be a type literal like this instead? I mean, let's give it a try. I am confused. And this should also be a count. Okay, never mind. Let's try it out. Let's try it out. Counting semaphore. Yeah, now it's properly 1L here. Okay, this works. Okay, now over here we want to actually use a counting semaphore with a specified count. I have no idea how I even got this to work last time. Wait, shouldn't this be... Why is it causing trouble? Kind unification failure. We need the count as the first. Okay, and this will now be a binary semaphore. Let's go block. Binary semaphore. Global include the semaphore. I mean, this should be moved somewhere else, like. You know, maybe putting it inside the nominal wouldn't be bad. Like, in case you're wondering, we could maybe... Yeah, we could do something like include a global and then return an empty string, like why is this a problem? Okay, so this isn't a good place to put it. I have to put it literally. Whatever, we'll put it in all of these. I'm just trying to fill things out where it would be the most convenient to actually put it. Okay, how about we do something like real nominal. And then we could put yeah, and that would ensure that this actually gets included every time the stupid thing is used. I mean, the counting semaphore is used. This is actually the term segment. Right now, instead of here, this is in the bottom up segment, so we're not getting type inference for anything when I hover over the variables. And this gray, that's a special operator. It takes in a type and turns it into a runtime variable. And that's useful when doing type inference like this. The real nominal will just return a runtime variable of this macro type, and it will convert it to a type, so it will just show up as this macro. And this is perfectly fine. Yeah, I have no idea why I didn't do this earlier. I should have done it. So, yeah, this should be fine. Well, let's try building this. If we build this, I'm guessing it should still work. Oh yeah, perfect. It's amazing how it was pretty much wrong everywhere, but we didn't even notice. Oh fuck. Counting semaphore. Count scope. We also need a binary semaphore. This module was created before we had macro expressions, so we could only use variables. So I had to put everything in here by hand, all the types. I mean, and that's bad. Yeah, this is an amazing solution to the problem of including the right types. I should change pretty much all the modules so the includes are done inside the nominals like this. But I guess this will have to be the first in line. I'm not going to go over it right now. So okay, console pi din You know, I hope I didn't have it paused for too long. I just had to take a short breather. Okay, I mean, all this works. I think if you look at the console log, so here, binary semaphore thread scope system. It's initialized to 1 and it works. If you look at the printing function, yeah, this does look a lot nicer than what we had before. It's not a single print, but it's still not bad. And okay, here we have the console CUDA. And then the layout type, fuck that. We'll mess with those at a later point. What's important is that we have this this printable. I mean, they will call this write template, write underscore. They definitely shouldn't be calling one of these. And what we have to do next is also do a Python version of all of this. We don't have to, but we will. I mean, I could have aborted all of this once I figured out what the problem was with the reduction kernel. And after we refactored the semaphores, but we'll go all the way and do a proper refactor of everything. Okay, we don't need the semaphore anymore. Wait, yes, at the very least, what I want is to get rid of this. We don't need the CUDA semaphore. We shouldn't need it. And if we go compile this again, build, do we have the semaphore? Yeah, yes we do. And wait, are we not importing it anywhere? Yeah, now it's importing it, but after I do this, no it isn't. Oh damn it. So the change that I did to the semaphore to print it inside the global isn't working. Oh, why is that the case? Let me pause. Oh yeah, I figured it out. Today I'm pretty fucking brain dead. The reason why it's not happening is because the code generator actually needs to see the global statements in order to actually put them in. And if we put that in the type, it won't show up anywhere on its code generation path. That was the problem. So yeah, maybe just putting it into acquire was the most expedient choice. Whatever. Console CUDA, let's build, no, let's build this. It's, oh no, it happens after the global type. Oh my god. Here's what we're going to do. Yeah, we'll just have it be in here. Let us also just check out whether we need the cooperative groups. Build, we don't have cooperative groups anywhere. But we do need them, in fact. Okay, let's do this. Enough fooling around. Now everything finally works, and we won't worry about this anymore. This is the console CUDA. We also need maybe the console Python, but we'll instead move it into the extended into core extended. Okay, now it's here. And it can see it. We're going to also move this into core extended. For fuck's sake. Open CUDA. We also do a console Python. And unfortunately, this open core CUDA. Okay, what we have to figure out next is what will we do about this printable thing. Oh, it has to go into console. No way around that. And this will have to go into okay, let's do printable. We'll put the printable here. And in fact, we'll put all this. Okay, we'll put the printable here. The console config. We'll have to come here. Open core base compile time. Oh yes, and this is it. Okay, this will go into the utils maybe. Okay, here we're going to be moving things a lot. Utils. Sure, let's make this console. Create file. And we are going to console copy. Let's yes, move them, replace them. Oh no, we don't want to move them. Or maybe we do. Do we want to move the types to? Yeah, I mean, let's put them in. Let's put them all in. Don't ask me again. Actually, What the fuck? Replace. Okay, good. Let's look at the packages. Okay, we have the types here. Utils here. We're going to export the console types into the enclosing module, so we can just use write ln and write ln. I mean write ln and regular write, and I guess we'll have to figure out where to put the semaphore, but never mind. I mean write ln semaphore. Open core base, open compile time. Oh, yeah. All of this. This needs to be in utils. Utils create console config. We don't need this. Oh yeah, perfect. Now we have what we need. Oh, sorry about that. Yes. Now what we'll do is implement console Python, and when we do the printing for the tensor, we'll just be calling what we'll be calling is we'll be calling. We'll have a template function for the write. We also need utils. We'll have a template function that's for the write, like here, directly in over here in console. We'll have something like write underscore, and it will call out to the relevant backend. That's the way to go here. Yeah, we're going to have to factor out the functions for putting the formatting and the separators. We don't want to flush at every single opportunity. Okay, you know what? I don't really feel like programming anymore. We'll do the Python version of this tomorrow. Let me just run it to see whether it still compiles, and then we'll close here. Build. I've been pretty tired the whole day today, so yeah, this builds. Redesigned the console module. Let's see. Yeah, we're going to have to fix that later. We still have to do the Python version. We still have to do the Python version. Not done yet.
Yeah, we'll focus on the Python version, and then we'll bring all of this together somehow. I'm really curious how I'm going to deal with the tensor printing, because it's using write for everything, and that would end up flushing the output. I guess we'll have to do a version of write that doesn't flush the outputs. No choice but to do it that way. Now we have to do. Yeah, now we'll have to be very careful where we do the outputs. For the tensor printing, I think we're just going to flash at every opportunity, because it would be too difficult to do otherwise. I'm thinking about if you have to keep track of compile time stuff, when also dealing with the loops for the tensor printing, it will get complicated very quickly. So it's fine if we just print at every opportunity. We have fixed the main issue with that is causing the incorrect results during printing. So we can be pretty happy about today's session. We did very good work, but we need to go a bit further. We can still go further, a lot further. And now it's time for me to rest. At some point I really need to sit down and put all of these videos together. I've been just doing recording and not even bothering with putting them into the timeline. But as I said, I'm going to do this after I finish integration with LDAC. Who knows how long that will take at the rate I'm currently going. It shouldn't take too long, but we keep going on all of these side quests. Even so, it's important to actually do the spiral libraries properly. What we are doing here should definitely be helpful to other people trying to do GPU programming. See you later. Oh, another late start today. But let's do some work. Now, where are we? Yeah, we have to do the Python version. Also, let's do some more testing of this. Let's see whether this prints out the lists correctly. 1, 2, 3, 4. Oh, wait. It's amazing how sometimes even I forget to put in semicolons instead of colons. I think F# in its latest version puts in a warning if you put in a comma instead of a semicolon in something like a list or an array. It's a hard habit to break. Yeah, maybe I'm really enjoying this summer, what with the swimming and then gaming. And I feel bad that I'm not doing enough programming, but that's the way it goes. Oh yeah, this is pretty nice. I definitely like this. Let's also din it so it's a runtime variable. In fact, let's check out how it shows up in the code itself. Oh yeah. And, because the list is known, it all gets inlined into the print statement. And I do find that impressive. Okay. Honestly, I'm not really sure why I've been enjoying tactical games so much lately. I kind of got back into it when I started playing Reverse Collapse, which is a great game, genuinely. And then I got back to XCOM. I've been playing a Long War years ago, but I never really actually beat the game fully, and I kind of feel like I've been cheating the whole time at the Long War and never really got a grasp on it. But now, because after being bad at it for like a lot of time, I finally get a sense that I have a handle on it, and it's very euphoric. This campaign, I really am doing very well. I had to abort the first one, and now on the second one, I have the air game completely down, and I am pretty much slaughtering the aliens. Wait, did I get an error? Sorry about that. Our recursive join points must be annotated. Okay. So something like this, I guess. Don't tell me this isn't it. Oh my god. Okay, maybe, yeah, like this. Let's try this. Maybe I should work on these annotations. Anyway, it built finally. Now let's see what will happen. It prints the first part, then it prints. I have no idea what this is. I guess this is where it prints the list. Let's run it. Yeah, it works. Wonderful. The last time I played Long War, XCOM Long War, actually it was so fucking annoying to keep crawling across the map. You can kind of be in a fight with a pod, and then somebody could come to you from the side and completely wipe you out. So you have to be extremely careful how you move your units in that game. And what I did, it was kind of memorable, because there is an item called a battle scanner in that game, and when you activate it, it shows you a little. You have like 2 charges, and it shows you like 5 tiles out of vision, whether the enemies are there, or maybe 10 tiles, something like that. I ended up editing the game configuration files to give that item like infinite charges, and then I increased the range by quite a bit. So that allowed me to see much further ahead where the enemies were. In essence, I gave myself a reconnaissance cheat. And then I turned all my units into assaults that are wielding shotguns. I also gave them a run and gun. And so pretty much it was kind of fun. Pretty much every fight was them run and gunning and then just wiping out the enemies. Because in using alpha strikes, which are ambushes. And yeah, that was fun, but I got tired of it. And it's not really the
the way the game should be played. So now that I'm playing it, according to the rules and actually winning, I'm very happy. It was quite bothering me that I wasn't good at this game. Okay, so sorry for a segue. You probably aren't watching this video anyway, but if you are, you probably aren't watching this for my random gaming talks. But just constantly doing programming is probably would probably be boring to you as well. So maybe talking about some of my gaming experiences might be a good way to break the monotony. I've been watching some Girls Front Line 2 videos, and the game isn't very successful. So who knows how it will turn out. And I've been hearing that the gameplay isn't very fun, which is, I don't know, I have high expectations because I've played Reverse Collapse, which was honestly great. And the cutscenes for Girls Frontline 2 are very good. You should watch them even if you're not interested in the game itself. I did watch something like an action anime that was built in the way Girls Frontline 2 cutscenes are, like, not an anime, but something like a 3D anime. Is that even a term, like, for 3D anime in 3D? I think I saw some Chinese stuff, but it's not like that. It's kind of like in Genshin Impact style. Okay, well, let's focus on programming. So yeah, right now what we've done is tested the lists, and we can be sure that recursive unions work for the new function. Now I'm thinking, what is the difference between the union and the sum type? In Haskell, I tried looking for a union type and got nothing, and it turns out that Haskell has something called sum types, which are very similar to union types, and at this point in time I'm not even sure what the actual difference is. Maybe one of them has union cases that are unordered and the other does. The thing about this, the lesson that this brings to mind is that some people are pretty precise with their language, and unfortunately I'm not one of them. This is why I like having the machines type check everything I do, and because I'm not precise, so I'm not really good at doing very precise log mental simulations. I think my thinking style is more to do like many simulations in parallel that aren't very precise. I'd expect, the best mathematicians to be able to do long simulations, but very precisely. Honestly, I'm not good at math at all. You'd expect that a person like me would be good at that, but I find it incredibly boring. I try getting into math, but it's just, it's not much different from talking to yourself. And I really want to talk to machine. I like it. I like programming because machine gives me some kind of feedback. I write a program trying to do something, and then I run it, and it's wrong. So I play with it and try to get it in the shape, and the machine is guiding me towards the answer. That's really why programming is fun. I get the feeling that when I talk I'm a bit too tense. I should relax a bit more. So okay, we have the console CUDA down. I'll just copy paste this for now. And we'll do console Python. And of course, Python doesn't need all of this. It doesn't need
binary semaphore or warp synchronization. So okay, let's. It doesn't need to open Corcuda. And what exactly does Python need? We're going to have to figure that out. Let me pause here just for a bit. I'm going to do some research on formatting. I'm back. Let's resume. First, let's try test out how the Python format actually works. Like, we know a little bit, so let's put a print, and then, okay, of course this runs. And we can use format on print and 1, 2, 3. And what happens if we try that? Absolutely nothing. Okay, so this is how format works. You can use this to splice in variables like this. In a way, it is similar to printf. Suppose we put double curlies like this. Yeah, now it prints out curlies. And if we did yeah, it doesn't have to be open or closed. Okay, great. I mean, we have everything we need simply based on this. Let's go into console Python. And in particular, we have to change this. And now, we don't need the separators like this. In fact, actually no, we do. We'll just put them in like so, pretty much everywhere. Oh yeah, and for floats, we have to do the floats a bit differently. Okay, how was it? How was it done before? Like 2f6, was it like this, or 2 6f? Oh yeah, it was like that. Colon period 6f. Yeah, great. Oh, okay. Now, what about the flush? Oh yeah, that's one issue. We don't actually need a special thing for Python. Let me just think. Yeah, how are you going to take care of the new line? I think print has something. Print. It has end. String or none equals n.
Yeah. It has end. It also has separators for the separate values. If we go back and look into the old console, like here we're doing the print in Python. Oh yeah, we do have the end. I thought we'd also have the separator, but I guess not. Oh yeah, we don't have the separator because we are only printing one thing at a time to the console. I mean to the terminal. Okay, so but yeah, we can also put the new line directly into the format string. Let's see whether that actually works. Something like, if we do this, what will happen? Oh yeah, it prints out the new line. So we don't have to put in the end specifically. We can do. Okay, we can do this. Print fmt, and now we do a format. And in fact, we don't have to do anything explicitly in the format. But if it's something like a tuple, it will put parentheses around it automatically. So let's see. Real match str with we're just testing whether it's a tuple. If it's a pair, okay, it's kind of awkward. Like, it was awkward to test whether something is a tuple even in the CUDA core kernel launcher. We don't want to put in a tuple if it has something like if it has unit types, but it shouldn't be putting the unit types into the format anyway. But what if it's empty? We also have to think about that. If it's empty, okay, we'll do str, and this will automatically put the parentheses around str when it's a tuple. I could just get. No, we cannot get the free variables. We need the term variables. Okay, never mind. Oh fuck. Let's do this. Let's do it like this, and there will always be an empty string because we'll be passing the new line into the format. The macro needs an annotation. I mean, doesn't it have it right here? Oh wait, crap. And otherwise, we'll assume that this only has a single variable, so we'll put in parentheses like this. So yeah, this is how we're going to do the printing on the CUDA side. Yeah, not bad. So I guess we'll have to test this next. Okay, let's test it. Okay, let's go into console. Could create config. Utils, create console config. Yeah, who's going to remember how to do all of this by hand? You know, while I was applying to some jobs like last year, there was one job which sent me some, which sent me to something like, and it's not a hacker rank page, but something close, and it pretty much quizzed me on endless stream of .NET trivia. It was fucking ridiculous. You see, it would be basically impossible to pass that without cheating or photographic memory, or being some kind of callback key only does those specific things. Like, I cannot fucking remember the stuff that I wrote like yesterday, and there's no way I'm going to remember the exact specifics of .NET libraries that I only maybe used like 2 years ago. I mean, I guess it's the case that bad jobs filter themselves out. But then again, right now it doesn't seem like there are any good jobs out there at all. It's ridiculous. I wish that there was more to programming than what currently exists. Right now, the job market, as far as I can tell, is still very bad. I only did I did some application in 2023, and now that's when I got that part-time job, which allowed me to upgrade the rig, and it's fucking amazing. It's what, August 2024. It's amazing how time flies. Who knows? Maybe in 2025 it will get better. But there's always a danger of there being some stock market crash and it getting bad for a really long time. I mean, it's not like I need the money, so who cares? And the real projects are the ones you do for yourself anyway. Yeah, I guess when you are working for other people, you have to use the tools they give you, and they're not very good at picking the tools. But when you are programming on your own, you have the complete freedom to pick your own poison, so to speak. So that's really where the true measure of a programmer is made. Okay, so we have write ln and write l. Okay, let's test it out. We have the console here. Console Python. And let's build this, and we'll see what happens. Okay, it did the right thing here, but it did the wrong thing here. And this is what exactly? Oh, this is... Okay, I'm not sure what this is. I guess... Yeah, this is what... this is the start of the list, I think. This is what happens after it prints the option type. So I guess it... oh yeah, it has a pair. Okay, so like this. What if we did it like this? Let's try it. Oh yeah. Yeah, as you can see, it prints things out. Perfect. Yeah, these two functions are very similar on the CUDA and the Python side, but they're not exactly the same. And maybe it's justifiable to copy-paste here. And anyway, what you have to do is make a version that does a backend switch. Let's do it. Backend switch. Inal write ln add x and then backend switch Python fun and then okay, let's put that here. Console Python write ln and then x. We also need the CUDA. Oh, not bad. And now, yeah, I suppose we can test this out. We'll keep them mostly the same. And if you look at what's happening here, yeah, it prints it out on the host, and then now it's compiling, but dnvcc is compiling the code. Right, it ends up being printed after it exits the kernel. I mean, and this none is what gets returned over here from main, and it prints that out. And all this is on the GPU. We can see that A is false. Oh yeah, perfect. And now what we want to do is check out the tensor printing. I've been meaning to maybe return these in a record, but it doesn't matter. Okay, let me just raise the table. I need to get up a little, stretch my legs, and let's see, where's the tensor? Where's the printing? I think Statica, we have, oh yeah, here's the printing. Here's the tensor print. Alright, what the hell is going on here? He just has to go over the elements in the tensor body. Here's print tensor body. Yeah, this is pretty complicated. Okay, well, what do you think? Here you go, write ln. Let's do a regular write. Open base. Open tensor m. Oh yeah, we have to pass in the console config. Let me pause a bit again. I had some time to think about this, and what we're going to do is something unexpected. We're going to actually make good use of higher ranked types. Okay, let's see. Where is the... Now, instead of passing console config, what we're going to do is pass type write ln for all what t results in a unit type. Yeah, now this is an interesting way of doing it. And we can actually put this printable thing in something else, like in core base. Okay, for now, let's just leave it here. So we have tensor print. Write ln write funds and yeah, here we are using the high rank types, and this is very useful because it allows us to put a generic type on the functions that we're passing here. Previously, without high ranked types, we could only pass a write for a very specific type. Okay, here we go, the printable tensor print ln. Okay, what the hell? So what exactly do we want with this? Why do we have to do this? Well, the main problem with let's go into console CUDA. And this write line and this write, they all go through write semaphore. And the write semaphore acquires a lock. So if you call this function, if you call write semaphore from another function that also calls write semaphore, it will create a deadlock. And what I meant is to pass these functions through into printing without needing to acquire the lock. But it's kind of complicated. This stuff with the locking. Maybe this is maybe what we did here wasn't a good idea. Or rather, maybe we should move this locking to something similar to what we had before, like in the semaphore module. Because there have been cases in the past where I would just call tensor print ln directly. And the reason why I'd want to do that is because it allows us to pass this I, and that's the size of the tensor to be printed. By default, if you use console.write ln, it will only print out the 100 elements, and then put these ellipses after that. But over here we can just specify the limit directly. Of course, it can only be called on a tensor, but I don't know. I guess I should think about how I want to do this. I mean, do I want to move this functionality somewhere else and make the semaphore explicit? Let me pause here. Okay, change of plans. We're just going to factor this out. Yeah, I guess I will just do it like this. Like, whatever. It's not the ideal solution, but it will do the job. And then for tensor, I guess, okay, well, where did I put? Okay, let's build this, and now if we compile this, it should not work. At least in a multi-threaded fashion. Yeah, the print statements are getting executed in parallel, and that ends up making a huge mess. If we do what the hell was it called? Oh yeah, this is in console.write, single threaded. We also need a version in okay, in console. Let's name this right. What the hell? It didn't work. I didn't build this. Okay, what's the problem? Oh wait, I'm just calling write directly instead. Okay, console could single threaded. Oh no, wait. Fuck. This. Great. Now Control F5 and it runs correctly. I guess we'll just have to get used to writing single threaded in CUDA. And we can also write, we'll also be able to write a single threaded tensor println, something like that.
Yeah, not bad. We have the tensor. I guess that's it for as far as the printing is concerned. What do we do next? Yeah, I guess we can get back to actually working, to actually doing GPU programming. I mean, it's not like this isn't GPU programming. Yeah, okay, let's commit this. We'll release a new version of the language. Yeah, no, actually not yet. Let's get rid of this console. We'll also get rid of tensor printing. And we have a lot of problems now, it seems. Open console. Oh yeah, we also have the error print here. Do we need to do it here? Couldn't we do it in... oh yeah, we need the semaphores. I mean, each of these have their own... it seems like we have a bunch of printables for SAList and SAM. But okay, now that we have this, would it be bad to actually do what I suggested and in printable to simply pass the necessary functions into it? Oh, okay. I mean, okay, let's try it. It's kind of... It's a lot of work to move printable into all the printable instances into core extended. So if we do this, we have the right ones. And okay, let's go into core extended. Right, ln. Right equals right ln equals right ln. Could we have a better solution than this? Like instead of that, could we somehow move the semaphore functionality into okay, let's make this
printable, and we'll move this into maybe base. We could do it like that, and we need to change this to printable fonts. Not bad. We don't need to care about the console config. Oh no. Let's take a look at all of these cases. Unbound module, error print, write, ln, printable. And yeah, we're just going to add this in a bunch of places. I mean, shouldn't it be adding... Oh yeah, this is just a generic function. Oh, we don't have the console. Oh yeah, this needs to go as the first argument. Oh no, we don't have the... We're going to have to move these tests somewhere else. Like, where the hell are we even testing this in core CUDA tests? Okay, this is going to have to be moved somewhere else. Open. I've created a directory. I've created a directory, I mean, and then not the core base, but this will just move everything from here to core tests. Let's get rid of this directory. Okay, not bad. Open core CUDA. Open core X console. Oh wait, we don't need to open that. I guess we can do it like this. No, let's see. Which other errors do we have? Oh, we don't have a bunch of them. Oh, fuck.
We were really dependent on having the console be in core base.
Oh yeah, we're also forgetting something very important. Whatever. Let's comment this out for now. We'll figure it out. We can test here. Oh my god. I mean, okay, this is in Ladakh. We can just open core ext here. No more problems. Instead of using semaphore, we can just use console single threaded console write. Oh fuck, what the hell? I accidentally pressed Ctrl Shift V instead of Ctrl V. Oh, I hope I didn't lose any of the work. Oh, I think it saved it. Oh fuck, it didn't. Console tensor. Okay, I mean, I'm not going to bother moving all the tests. Instead, we're just going to comment out what we don't need. Variable console. I mean, okay, here we can just open core ext since this is in the game itself. And this is in the ML library. We can just open core ext. Open core ext. Maybe we could do some renaming. Core. We could name this console tensor println. Fuck, we're using this literally everywhere. Okay, here's what we're going to do. Replace all. Problem solved. Open core ext. Okay, now we don't have any more errors in the entire project. Now we can finally commit to this. Moved the printing outside the let's also release a new version of Spiral. Okay, so we added int f and static string concat ops to the language order to string in the ML. Let's see. Yeah, that's what it was. This is what it was called. We need to put in one here. So yeah, this is not bad at all. Not. In the ML. No. Oh yeah, no. Oh, I keep forgetting. we're still not done with this. What we need to do, yeah, in both of these. We have this printable here, but we're not. Yeah, we're passing config instead of write and write ln. So we need to apply t. What the hell? Oh yeah. I guess yeah, it's expecting t, and then yeah, x of t. Let's just let it like this, and then what you need to do is apply the config is new line false, and then finally the element itself. So instead of passing configs into a printable, we'll just pass in this. Yeah, perfect. We also have to change this in the other module, console Python. Oh yes. Oh, perfect. Now let's actually not commit, but run this to see if it still works. And the thing is, we're going to have to print a tensor, create one and print one. Oh, it ran very quickly. I guess, yeah, there wasn't any difference, so it compiled instantly. What we have to do... Okay, let's take a look at some of these primitives tests. Those are printing the tensors. Let's build the file. Okay, some of the tensors here are being printed, and what's this? I guess this might be the print statement that's left over from what we were doing before. So let's see, where is that? So this is it. Yeah, we're going to have to change this, but yeah, whatever. Let's console write on, and then A, B. Let's see what happens now. Oh yeah, we need also console single threaded. And you know, do we need to put that explicitly in now? Because all the printable functions are calling the functions that we are passing into them. So we could, yeah, we could do what we did before. Let's go into console. We have single threaded. Okay, in tensor print. Wait, and I mean, I'm just going around in circles. Let me just pause for a bit. So I'd really like it if I could avoid having to write console single-threaded every time. Preferably console write line should just work as it is. Okay, here's what we're going to do. We have this single-threaded write. Now the only question is, do you want to make a non-locked versions of these functions, or do you just want to return a record that okay, okay, let's do it like this. Printable fonts. Write equals I guess we'll have to do both. Okay, let's do this. Yeah, we can actually do this. And in fact, what the hell am I... Yeah, I just realized I did something silly, but it's not a big deal. Okay, this will be write. This will be write ln. Yeah, it would have been a lot smarter to just do it like this instead of putting single-threaded directly into console CUDA. But arguably, it wouldn't be bad to lower the amount of single-threaded, because the backend switch evaluates both cases always. So it needs to be done like this. And this is the optimal way. This is the optimal way. Write ln, and yeah, I forgot to remove this one. Now we have write ln, and we have write. We have the printable functions. We can pass that into TensorPrint. Don't do locking. Please don't do locking on the CUDA side. No need to use this one. Yeah, in fact, there's no need to use it at all. There's no need to even have it. And we can just do write ln as it is. Okay, and in tensor, let's go into tensor, and instead of passing them in like this, printable functions. Yeah, perfect. This won't lock them up. Even so, oh yeah, we might if we use TensorPrint.ln, we might want to use allows passing the printing length the tensor doesn't do single-threaded locking on the side. And we're probably going to change TensorPrint.ln to something else. Okay, let's D, Control F. And we are going to change this to maybe just okay, let's do write ln. And this will be TensorWrite. We don't use this directly anywhere, so it's fine. Maybe we should rename printable to writable. I mean, whatever, it doesn't matter. We can do Control F maybe later. Okay, this is fine. Yeah, do we have any type errors? Oh yeah, we should bring this back after all. We have the single-threaded back again. So useful. Useful when what? When what? Write and write a line. Already use this one automatically. It's only useful in doing custom printing functions. And we need to in fact use it in the tensor module. Let's do this. Make sure does uses if you think about it, it's kind of a shame that the CUDA library doesn't already have this function. So Spiral does give value that just programming in raw CUDA doesn't. Let's see, now we have the tensor, single-threaded, fun. Now it will do locking on the CUDA side. And we could I mean, usually you'd want to use write a line, but we can also do a write version. Not bad. Let me listen to this again. I mean, I'll get tired after a few hundred times. Single-threaded backend switch, printable fonts. Okay, we have a bunch of. We've done quite a lot of stuff. Console tensor write ln. Did we do something wrong? Why is there an unit argument at the very end here? Yeah, like this. Let's also run this again. Yeah, it feels like something's wrong. Maybe it's a deadlocking. Okay, let me stop the music. Yeah, it's definitely deadlocked. Oh yeah, we haven't removed this. Or rather, we undo that and then it put it back in. The only way to get past the deadlock is to terminate the terminal directly. I know that from experience. Oh wait, I forgot to compile it. Shit. Oh, perfect. Now it prints correctly. Okay, perfect. Now, what about the other test? Let's build this. Oh, let's go over this. The results are still wrong. We haven't fixed that yet. Okay, but here A, B. I mean, why is it constantly the same thing? Okay, minus infinity 0. Yeah, that's just a neutral element. Oh yeah, it does work. The printing works beautifully. Sorry, I accidentally pressed the right mouse button. Oh yeah, this is nice. This is nice. And as I said yesterday, in yesterday's segment, the reason why we're getting the wrong results, and in fact, why the assert was constantly triggering when we were using it, is simply because the cooperative groups reduces using a butterfly reduction. Butterfly reduction. And I showed you this slide yesterday. The butterfly reduction uses the exclusive OR shuffle, and compared to the other versions, this ensures that all the threads get the same result at the end. But the unfortunate thing is that we need to make the reduction function fully independent of the argument order. Okay, I remember having some asserts in something like the primitives. Let me put a bookmark here. And okay, what's this? Yeah, I think I put an insert somewhere and then tested that that way. But I forgot what I was doing yesterday. As I said, my memory isn't the best. I have many other things on my mind, such as killing aliens, local max, softmax, and discrete sampling. Okay. So let me show you how to do this. Instead of just returning the left over here, we need to make sure to return the left only if it's... I mean, okay, here it's fine. No, it's not actually fine. Else if A, elif then B. We want to return the lesser, and if these are equal, then what? Then we need to return the one with the smaller index. If second A less than second B, then A else B. And over here, we just do this, and this should be fine. In fact, I mean, it should never be the case that they have the same indices. And if they, I mean, but it's actually possible for that to happen right now because we're passing 0 as the neutral element. But if we pass, okay, if we pass something like -1, I mean, it may also be the case that this library will be run with the default integers that are unsigned, and then -1 would be huge, so you don't want that exactly. I guess this is only an edge case when we are comparing the neutral element, which is 0, with the JSON tensor. How exactly do we want to deal with that? I wish I could just put -1 here. That's what I want, but I also need to think about the unsigned case. So I suppose... okay, this is real complicated.
This fucking edge case is killing me. Let me pause.
Yeah, as it turns out, I'm overthinking this. I mean, even if this particular edge case, for example, even if in one thread it will return negative infinity 0, and in other some negative value that's not infinity but it still has an index of 0, that will still end up resulting in a 0 at the end of the reduction kernel. I mean, if there are no other values that are positive. So we just get the same index at the end. It doesn't matter if the ordering is being violated right here. It's fine. Like for example, if the neutral element, I mean the neutral element should never be picked if there is another element that has a probability greater than 0. I mean at this point. Oh yeah. What is the problem is this thing here. I nearly forget about this. Oh, damn. We were doing well, so well, but... fun J. And we need oh, this is so horrible. If second A less than second B, then A else B. Local map first. Oh wait, it does a reduction. So we don't... Okay, let's put in some comments. It's important that here and in oh yeah, I was just going a little into the cooperative groups to see if we are still swapping the variables. FAB, yeah. Okay, let's leave a little comment. Note that it is using butterfly reduction. The the arguments passed into F in arbitrary. I mean, it's actually, yeah, let's just put it as arbitrary. I mean, it's not really arbitrary because that implies it can be anything, but it will try out both orders. And the only way to actually preserve the ordering is to
stop using cooperative groups, reduce, and do our own version of the butterfly reduction, which arguably isn't that difficult. We could do it in a few hours, but I don't want to do that right now. It's not worth to do. We should do our own version that serves argument order. And the same goes for the scan, but I'm not sure whether it's doing the same thing for the scan. It's probably not doing a butterfly reduction for that. We can test it, but who cares? The same one. Okay. We can in fact do this, and then this is F32, and the probability probability equals convert probability. Okay, let's do it like this then. First, convert. Yeah, I think this is elegant. I hate rebinding variables to themselves unless it's really necessary. The less the variable names you use, the less you have to think about what to actually name them, and that's good. Okay, so I think this version should work correctly. First it checks the probabilities, and if they are equal, then it checks the indices and picks the lesser. The same goes for here. Okay, now let's try building this, and it should work. Spiral build file. Yeah, now as you can see, we're just getting results from 0 to 2. For here, everything is fine. Okay, we got rid of the... We commented out the write here. We also put in a join point, so there's less noise in the generated code. All of it will just call the same function. Yeah, perfect. Yeah, I'd like to apologize for, saying the CUDA devs were incompetent. It's not a bad thing to use a butterfly reduction, and I can't really fault them too much for not caring about the argument order. Maybe if I was in their shoes, I'd do the same thing. even though if I was doing a butterfly reduction now, I definitely have it preserved, the argument order.
So we don't have to deal with this complexity here. You know, instead of doing it like this, you know, AB equals we can just do this. A, B, else B, A. If second A less than second B, then AB else BA. We can just do that here. And we can, and then we can just do else. Else. Yeah, I think it was like this before. Then A else B. Else A. Yeah, now because of this we know that they're in the correct order. It will just swap them if they're not. And then it can compare them here. I mean, it doesn't really matter. It can compare them here, and if they're equal, it should return the leftmost. We're going to test this out, but it should work. Yeah, it still works. Now let's also test. Let's also test it with large inputs. Oh, 0, 124, 124, 124, 0, 0, 0. Okay, that definitely looks broken to me. Okay, is it broken because of this? Let's just save this here. I kind of get the sense that I did some kind of error, that I made some kind of error, I mean. Let's build it again. Yeah, my focus while doing this version was less, so I kind of feel it's more likely that I made some kind of reasoning mistake. Oh, they have the same error. Damn. God damn. Oh, I should be 0 and 2, 0 and 2, but... Oh, this is fucking crazy. Okay, at least we have the print done. So what are we going to do now? Oh wait, fuck. We have... we should be getting the... this will just end up returning the neutral element. I mean, at least that's what I think it should be doing. So it won't exactly do what we want. Even so, it should be just giving us zeros everywhere. Why do we get... yeah, sometimes you get 124 instead, and that... oh yeah, okay, I see. Oh fuck. Okay, before we fix this error by, just doing this version, and what this reveals is that this neutral element is in fact a problem. Let's see if we put in -1 here, what exactly will happen. We can also just put in limit max here instead. But okay, let's try running this. Okay, what if we put limit max? Yeah, now it works as expected. Yeah, this should always end up returning, at least when it was done like this previously, it should always end up returning 0, 0. So this is always just the original inputs. And then this returns the leftmost element. But why does it keep returning 124? We need to root that out. Let's have it be wrong like this. And we need to make sure that this part actually just returns the leftmost element, even if it keeps getting past 0, 0. Okay, here it's 0, -1. Damn. I mean, why don't we see -1? Yeah, it's not returning the neutral element. The reason why it's 124 is probably something else. Oh my god, how much effort will this thing take? It's insane. I cannot even imagine how long we are spending on this. Okay, console.write ln, and we can just put in x, thread id, thread, and the block index is the same everywhere, so it's fine. We'll build this, we'll run this. I kind of need to reinitialize my brain. I was doing... we were debugging this a few sessions ago. 41, 41, 41, what the hell? I mean, okay, here is 0. But why is 31? Why isn't the 31 thing also all 111? That's unexpected. Oh, what the hell? Oh, there's something wrong here, and it isn't something that I thought was wrong previously. Yeah, here we see a printing bug. It's not printing correctly. It put it in right in the middle here for some stupid reason. And I think this is an error on the CUDA side. It's not printing things out correctly even when we are using a semaphore. But of course, it's still much better without it. Okay, so 31. Okay, this is very confusing and we need to figure it out. Otherwise, let's do this. What happens if we do here? Final build file. Uh, 31. Wait, what? Okay, this is an inclusive scan, and it should have like 3 elements. Okay, of course, the third element should be 1. Okay, I get it. Okay, so the inclusive scan is correct. What about the probabilities? I mean, the probabilities that we are propagating. I mean, if this is working correctly, the probability should be the same in every thread. And here it is 0698. Yeah, it's obviously not correct here, and it's 0 everywhere else. Okay, I see. So that's the problem. I mean, so I guess the last thread actually gets the probability that it generated. Why exactly is that the case? Yeah, I mean, yeah, the last thread gets the probability that it generated. So if you do this reduction, wait, I mean, could this mean that this so-called reduce is not sharing the probability correctly? I mean, this could be a problem on our own side. Even if there's something wrong with the kernel, it should still be... like, okay, take a look at this. This just iterates over all the elements and returns the first one. Of course, since it returns the first one, the result should be the neutral element. At least based on this part. But if you look at if you then look at block reduce 2D, it will go into this. Then it does a. Okay, this wouldn't be safe, but it does a bunch of CG reduces. Let me pause for a bit. Oh yeah, I think I think I had an idea, but okay, it's kind of weird. So, okay, if we suppose we put in -1 as the neutral element here, what exactly would happen? Would that fix the problem? Yeah, now the probability is literally 0 everywhere, even in thread 31. Like, I have trouble understanding why the probability ended up being something other than 0 in thread ID 31, but what's happening is that we aren't actually doing any... we aren't using shuffle instructions to share the values across all the threads. Instead, we are just using the butterfly reductions. And we are also doing this second A less than second B. And in the case where the neutral element is 0, and the J is also 0, that will end up returning an arbitrary value. That's why we were getting that error. And the solution is to put a limit max here. Limit max. I also said that I wanted to put -1 here, but maybe we could redesign this so we are using limit max also. That way it won't matter which kind of integer we are using, whether it's signed or unsigned. Limit max. Now it should always be selecting one of the actual elements. And I don't know why I didn't think of that before. And okay, let's also take this and we'll put it back into here. If second A less than second B, then AB else BA. Yeah, that's perfect. And this, I think what we have here will only really cause problems if a user tries using tensor, which is like 2 gigabytes large, because then it will be comparing with this thing with the limit max. But whatever. I mean, it's always even if the limit max, even if it ends up comparing with the limit max in some case, it should just select the leftmost one. So maybe even in that case, it would end up being correct. It's fine. You're right. Now Okay, let's get rid of this. Let's build the file. I mean, this is a good lesson. You can see very clearly how the correct selection of neutral elements makes a huge difference. Yeah, not bad. Yeah, and this kernel is a lot more readable since we are doing this swap at the very start. Let's run it a few more times. Perfect. Let's also run it with the small input size again. Not bad. Yeah, great. I think it's only now that we can release the new version of the language as well as commit this. Okay. Great. Cooperative groups. Okay, what do we put in? Let's see. We fixed the error in the discrete sampling kernel. Redesigned the console module and fixed error discrete sampling kernel. Requires spiral v2 what, 12.1 or is it 13.1? Yeah, it's 13.1. I really need to keep notes of which spiral version we are on in the commits, at least occasionally. Now let's also commit this. Now we'll close this. We'll close the extension host, extension development host. We'll go into here. What I just do is run this PowerShell script to release a spiral. PowerShell run, and it should run. Released v2 13.1. Perfect. And for now, let's continue programming in the extension host. The spiral will show up in a few minutes on the VS Code Marketplace. And that other place that I'm publishing on, OVSX. In case you're wondering, that other marketplace is used by some Linux distributions like Arch Linux.
it was kind of weird. I was releasing it just on the regular marketplace, and somebody tried Spiral and told me he couldn't find it. And then I realized that their package of Visual Studio Code that they are using on Arch Linux is using a different repository by default. So I also started releasing there. I should have done that. Released the script a long time ago. It's only very lately that I've been introduced to the benefits of shell scripting. And this script would be a lot harder to do in something like F# or C#. They don't have this built-in functionality for copying files and so on. I mean, they do, but it's a lot more verbose. I think it's very nice how this also has IntelliSense. Okay, so I think I want to leave some comments. Shouldn't. Right. Argument. On the CUDA side, it uses. Let's just make it a global lock to make sure the printing is thread safe and consistent. Put a new line at the end. Oh, okay, not bad. Add some comments. Yeah, one difficulty in doing all of this is actually writing out the functions themselves. But if you look at, for example, the console Python and the console CUDA, they're pretty much they're very similar to how they were done previously in terms of their architecture. What was hard was doing the design. That also took a huge amount of time, more than you would think. It kind of reminds me like when I go, for example, to the city to see a doctor or maybe to get some exercise. And for example, when I was going to physiotherapy, the actual session took only 20 minutes, but going there and back took like 3 hours. It's amazing, and the same goes for programming and design. Probably the time it takes me to type all of this out is maybe 10 or 20% it takes to actually finish it. I'm actually pretty satisfied with this. It still isn't perfect. I think NVIDIA needs to take a look at the printing, because sometimes it would print out the text incorrectly, but otherwise this is very good. It will be hard to make a bug report because I'm not sure how to actually. Yeah, it will be hard to make a bug report for this, because it will be hard to make a test case for this. Maybe I could just show them in the video how sometimes the errors would crop up. Never mind that for now. What did I do? Spiral. Oh, this guy keeps getting more and more users. And okay, this one is installing the new thing. I mean, am I getting new users? I think it's been stuck at this for a while. Who knows? Maybe let's give this guy a year and he'll have more users than I do. I'm wondering what he's doing. Okay, never mind that. I'll get in touch with him once we actually finish integrating the game with the LDAC. I mean, the ML library with the LDAC game. So what do we want to do now? Here we have the reduce test. Yeah, we can get rid of this. Yeah, this is when I did this assert. Just out of curiosity, if we do a scan instead, what do we get? Scan. Row scan. I guess it needs to be an inclusive scan. Oh yeah, it's either a map or a reduce here. Yeah, local scan. Let's do mn. And why is it giving us trouble? It's here that we probably inclusive scan. Oh yeah, okay. So let's try running this. I'm just curious whether we will run into the same issue with the scan. With the scan, it shouldn't be doing a butterfly reduction, so this might end up actually passing, but I'm not sure. Device side error has been triggered. It does trigger. I wonder if the problem is in my own code or theirs. I guess we'll never know. I mean, do I want to investigate this right now? I mean, probably not. Yeah, who wants to deal with that? Yeah, but if possible, if this really isn't doing a reduce, I like to test where the problem is happening. Okay, let's put in a join.
We already have this return second in the form, and yeah, I wonder from where. Okay, let's investigate this. I mean, maybe to you there isn't much of a point. Okay, here it's being called enclosure. Oh, it's getting called in quite a few places. Okay, let's do a printf. And actually, how about this? If v0 less than v1, actually wait. We're passing -1 as the neutral element. Oh fuck, what did I do? I accidentally sent it into the console. I probably pressed some key. Okay, printf wrong in closure. Oh, so it's getting passed in the wrong order in the closure itself. Okay, oh, that's fine. What about the other places? I want to just make sure that my own code is and this is yeah. For my own code, it's not printing anything wrong here. Let's continue. There are a couple other cases to check. Let's put in a print statement. Actually, no. Let's just go one by one. If it's wrong, it's going to be annoying to fix things. I mean, you can just do it like this, and then wrong in one code 2, 6482. That's fine. Wrong in one code. This is 86, 89. And we can kind of tell that this should be correct simply based on the argument order. And we have two more to take care of. This is 84. Actually 64 and 83. Oh my god. $64 and 83. Should this be like, yeah, this should be 4. Oh yeah, that's all of them. Let's run this. Yeah, it seems that the variables in my own code are all getting passed in the right order, as you'd expect, but it's only the CUDA kernel functions which are constantly causing trouble. Okay, for an inclusive scan, it's probably not doing a butterfly reduction, so I'm not sure why it's swapping the arguments around. My god, I have no idea what these CUDA developers are thinking. I mean, the fact that the exclusive scan for the cooperative groups in the cooperative groups namespace doesn't have a neutral element that we can pass in is inexcusable. They did such a bad job with that. And you can see that the libraries that I myself am actually doing in Spira are a lot higher quality. Okay, let's get rid of that. I mean, let's get rid of the reduce test. Oh, perfect. Oh my god, it's almost 5 p.m. Maybe it's already time to go to the beach soon. Okay, let's see. It turns out that this now the test figured that make sure that okay. Well, now we're finally done with this. I won't touch printing again or the cooperative groups, and we know how to share the. We've fixed the discrete sampling. So if we look at the layers, okay, now they're just using console.write ln. This should be fine. Okay, let's just run this once so I can reassure myself. that everything is still working. And after that, we'll go back to testing the game model. Now we should be getting the correct indices for the actions. It's printing a lot of things, but yeah, everything is correct. And if you look at the game model, I mean, there's nothing wrong here, at least I think. Instead, let's go into redact train. And yeah, we don't need this single threaded anymore. It will be such a pain to keep writing all of that out. Action, sample probability, output ID. So yeah, we're not converting the outputs to an action. It should just be printing them out as they come. Okay, let's build this. It's running the kernel. It's printing a lot of zeros, and yeah, now the indices are correct. Oh, perfect, perfect, perfect. And we can get rid of this and then put this back in, Control F5, and we should be seeing fold, cold, and raise in the output. What? I mean, did I forget to build that? That cannot be it. What the fuck, dude? I mean, yeah, it's this is what is getting printing here is this, and maybe we are just skipping over what's getting printed in the kernel. Oh yeah, yeah. Here the fold, call, and the raises are getting shown, and we can let's just comment this out. Yeah, perfect. And if we point this out and just do output equals ID again, and then build this, run this. Yeah, now we see the numerical IDs 2, 1, and 0. Oh, perfect. Finally, this shit works. It's amazing how long it took us to get to this point. But at least we can rest assured that the kernels are working properly. Oh, great. This is teaching us CUDA programming. So what do we do next? Okay, I'll stop here for the day most likely and think about what we have to do next. We have the game model. We are actually passing the data through the game. We have this graph. We have the output probabilities. I put indices. I mean, game model run. We have the game model and we have the data, but the data is not from the game itself. It's just something we made up. So I guess the next step would be to actually think about using the game itself to generate the data for the game model. That would be quite something. That's what we need to focus on, and that's the primary goal of this. I think I've been already making videos on how to integrate the ML library with the LDAC for a very long time. I'll only figure out how long this has been going on once I look back through the recordings, but maybe it's even been a month. I'm not sure. It might have been that way. But we will be done very soon. At least now we've gone through all the errors and can enjoy the fruits of our labor. Once we get it to run with the game, we'll use the game to actually optimize the agent. We'll implement the cross entropy method that I talked about in some of the other videos, and we'll see how it runs. It should be interesting. Hopefully it gives us something good to play against. Yeah, at the very start of this series, I mean, on integrating the game with LDAC, we started working on we started by importing a charting package and doing a chart, and we should finally be able to actually use it. We'll have to figure out how to integrate the training and the game itself into a single backend namespace. For now, we'll just focus on getting the optimizer to do something, pretty much anything. But we'll probably have it train against a random agent and see whether the error goes down. It should. And once all of that is done, I mean, once we get evolutionary training to work, we'll have to implement CFR training. I mean, there are three. We have to implement evolutionary training. We have to implement the CFR training, and then we have to implement also the subgame solving, which is specializing the agent to a particular game subtree. But that's for just the tabular training. It will be too expensive to also specialize the neural network for a specific game subtree. Anyway, let's stop here. I need to go see whether we'll be going to the beach. See you soon.